The story we were told is that we stopped going to the moon because of budgets and politics. But, what if the truth is far more unsettling? What if NASA's new Artemis program accidentally uncovered the real reason we never went back? It wasn't a conspiracy hidden in the shadows. It was a set of brutal physics problems hiding in plain sight. Problems that reveal the moon is a far more dangerous and hostile world than we were ever led to believe. So, let's explore this together. Heat shield failure. Here's what's supposed to happen. When a spacecraft returns from the moon at 25,000 miles per hour, its heat shield, made of a material called avcoat, is designed to burn away, carrying the catastrophic heat with it. But what if it breaks apart in chunks? During Artemis I's re-entry, that's exactly what happened. In over 100 locations, pieces of the charged shield material flaked off in ways that years of computer modeling never predicted. This forced NASA into a year-long investigation led by experts like Howard Hu, the Orion program manager, to figure out what went wrong. Here's the terrifying bottom line. The models failed because of the unique re-entry profile. Orion performed a skip entry, dipping into the atmosphere to slow down, then briefly skipping back out before the final descent. During that brief skip, gases built up inside the avcoat material, and without continuous heat to vent them, pressure mounted until it fractured parts of the shield. This single unexpected failure of physics is a primary reason the first crewed mission, Artemis II, was pushed to April 2026 at the earliest. It was a sobering wake-up call that returning from the moon is far more dangerous than we remembered. Radiation rivers. Imagine flying through invisible rivers of poison. During its journey, Artemis I confirmed a threat that is far more insidious than heat-deep space radiation. We are currently at the peak of solar cycle 25, a period of intense solar activity predicted to climax in July 2025. Solar scientist Lika Gahathakurta has emphasized that preparing for this space weather is critical for the Artemis program. The sensors aboard the uncrewed Orion capsule revealed something chilling. Simply by changing the spacecraft's orientation, by rotating the vehicle, the radiation dose inside dropped by as much as half. Let that sink in. The difference between a safe mission and one that could expose astronauts to cancer-causing levels of radiation could come down to which way the ship is pointing during a solar storm. This isn't just about having thick hulls, it's about navigating unseen cosmic currents at exactly the right angle. Artemis I carried phantom torsos named Zohar and Helga, packed with sensors to measure organ-specific radiation doses, confirming the danger is not uniform. The data showed that without proper shielding and orientation, a single, large solar flare could deliver a mission-ending dose of radiation in just a few hours. During the Apollo era, missions were short, but for the long-duration stays planned for Artemis, this radiation danger is a constant, potentially lethal variable that makes every moment outside Earth's magnetic field a high-stakes gamble. Deadly dust. The biggest nightmare on the moon might just be the ground beneath your feet. Forget gentle soft dust. Lunar dust, or regolith, is a menace. It's composed of microscopic shards of glass and minerals formed by billions of years of meteorite impacts. Unlike dust on Earth, it has never been weathered by wind or water, so every particle remains razor-sharp. Apollo 17 astronaut and geologist Harrison Schmitt learned this the hard way when he experienced what he called lunar hay fever. Sneezing, watery eyes, and a sore throat after tracking the dust inside the lunar module. Modern studies confirm his experience. This dust is toxic. Scientists like Kim Prisk, a pulmonary physiologist who has studied the effects for ESA, warn that these fine particles can lodge deep in the lungs, tearing tissue like microscopic knives. Because the moon has no atmosphere, the dust is also electrostatically charged by the sun, meaning it clings to everything. Spacesuit seals, visors, solar panels, and critical equipment. Researchers like Michaela Smith have shown that while it may be less chemically toxic than urban pollution, its abrasive nature presents a severe mechanical hazard. This isn't just an inconvenience, it's a relentless engineering challenge that threatens every aspect of a mission. Gravity traps. So, just imagine flying a spacecraft that's constantly being pulled off course by, well, invisible mountains. This was the reality for Apollo mission planners, who watched in confusion as their carefully calculated orbits would suddenly decay. The cause was a phenomenon they honestly didn't fully understand until much later: mascons, or mass concentrations, buried deep beneath the lunar surface. It wasn't until 2012 that a mission led by principal investigator Dr. Maria Zuber finally mapped these invisible hazards. The mission, called Grail, used 2 spacecraft flying in precise formation to create a really detailed map of the moon's gravity. The result was, honestly, stunning. The map revealed a lumpy, uneven gravity field with massive concentrations of dense material lurking under the large lunar basins. These mascons create powerful gravity wells, invisible traps that can pull an orbiting spacecraft down by hundreds of feet per second. This was first noticed by JPL's Paul Muller and William Sjogren way back in 1968, but it took decades to get the full picture. For Artemis missions targeting the lunar South Pole, a region of extreme craters and shadows, these anomalies make precise landings incredibly difficult. Navigating to a pinpoint landing spot is, well, like trying to sail through a sea with unseen whirlpools. Apollo crews had to constantly make corrections. For Artemis, which aims for pinpoint landings in treacherous polar regions, these gravity traps present a constant and unpredictable danger.
The moon rings.
What if you could strike the moon and make it ring like a bell? That's not science fiction. It's actually exactly what Apollo astronauts discovered, and the discovery was, honestly, deeply unsettling. The Apollo 12 crew deliberately crashed their ascent stage into the lunar surface. The resulting moonquake, which was monitored by seismometers placed on the surface, really shocked everyone. On Earth, seismic waves dissipate pretty quickly, but on the moon, the vibrations lasted for over 55 minutes. Gary Latham, the principal investigator for the Apollo seismic experiments, described it as the moon ringing like a bell. The reason is that the moon's interior is bone-dry and fractured, allowing seismic waves to travel with almost no dampening. A single impact can set the entire celestial body vibrating for an astonishingly long time. This revealed a world far different from our own, one that's geologically rigid and resonant. More recent analysis of the old Apollo data by scientists like Yoshio Nakamura confirmed another startling fact: the moon has a solid inner core, much like Earth. This finding supports the theory that the moon was born from a violent collision with a Mars-sized object in Earth. This raises a pretty profound question. If the moon is our planet's broken twin, born in cosmic violence, what other secrets are locked inside its strangely resonant interior?
Forgotten data.
Humanity placed ears on another world, and then, we chose to go deaf. For 8 years, from 1969 to 1977, the seismic stations left by Apollo astronauts sent back a continuous stream of data on moonquakes and meteorite impacts. Then, on September 30th, 1977, NASA sent the command to shut them all down. The official reasons were dwindling power from the generators and budget cuts to pay for the upcoming space shuttle program. We willingly abandoned our only active scientific outpost on another world, but honestly, it gets worse. In the 1980s, during a shortage of magnetic tapes, NASA erased and reused the original, high-quality television recordings of the Apollo 11 moonwalk. The raw footage of one of humanity's greatest achievements was wiped to save a few dollars. According to Apollo-era engineer Dick Navsker, who led the painstaking search for the lost tapes years later, it wasn't malicious. It simply slipped through the cracks. This loss is incalculable, as the original tapes contain far more detail than the broadcast versions we all know. These actions represent a pattern of neglect. We not only stopped going to the moon, but we also stopped listening to it, and even erased parts of our own memory of being there.
Soviet failures.
So, while America was busy celebrating its victory in the space race, the Soviet Union, well, they were hiding one of the biggest engineering disasters in history. The Soviets were just as determined to reach the moon, and they built a rocket to do it, the N-1. Designed by the legendary chief designer Sergei Korolev, the N-1 was a monster, meant to rival the Saturn V. But you know, it had a critical and ultimately fatal design flaw. While the Saturn V used 5 massive F-1 engines on its first stage, the Soviets just couldn't build engines that powerful. Instead, their chief engine designer Nikolai Kuznetsov clustered 30 smaller engines at the base of the N-1. It was an incredibly complex system that had to work perfectly. It never did. All 4 unmanned test launches of the N-1 rocket between 1969 and 1972 ended in catastrophic failure. The second launch on July 3, 1969, resulted in the largest artificial non-nuclear explosion in history, destroying the launch pad and nearly the entire launch complex. After Korolev's death, his successor, Vasily Mishin, oversaw the program's final, failed attempts. The repeated disasters forced the Soviet Union to abandon its lunar ambitions completely, a secret they kept hidden for decades. The story of the N-1 is a stark reminder of just how difficult and deadly the journey to the moon truly is.
The long gap.
Why did 50 years pass without a single human venturing beyond low Earth orbit? After Apollo 17 in 1972, the final 3 moon missions, Apollo 18, 19, and 20, were cancelled. Officially, the reasons were budget cuts and a shift in focus to the space shuttle. Decades later in 2004, a return seemed imminent with President George W. Bush's Constellation program, which aimed to put astronauts back on the moon by 2020. But, in 2010, President Barack Obama canceled the program entirely. A review had declared it over budget and behind schedule. The Augustine Commission, which reviewed the program, found it was on an unsustainable trajectory. Billions of dollars were spent, but not a single piece of lunar hardware ever flew. This history of starting and stopping reveals a deeper truth. Bureaucracy and budgets are convenient explanations, but they don't capture the sheer difficulty of the task. The long hiatus also led to a loss of irreplaceable manufacturing capabilities and institutional knowledge that had to be painstakingly rebuilt for Artemis. Each time we have tried to restart our journey to the moon, we have run headfirst into the same wall: the immense cost and complexity of overcoming the physics of deep space travel.
Artemis struggles.
If returning to the moon was easy, we would have done it decades ago. The Artemis program proves it's anything but. Rebuilding the capability to go to the moon from scratch is a staggering undertaking. The Space Launch System, or SLS rocket, took 17 years to develop. The Orion capsule's heat shield anomaly is still being addressed. According to NASA Associate Administrator Jim Free, the delays are necessary to ensure astronaut safety, with issues ranging from life support systems to launch abort batteries. But it doesn't stop there. The landing itself depends on hardware that hasn't flown yet. The new spacesuits being developed by Axiom Space haven't completed vacuum testing. And SpaceX's Lunar Starship, the vehicle designated to actually carry astronauts to the surface, has yet to perform an orbital refueling, a critical step that may require multiple launches for a single landing. Bill Nelson, the current NASA administrator, has had to officially push the timeline back, with Artemis II now scheduled for 2026 and the Artemis III landing no earlier than 2027. Each component of the Artemis architecture represents a monumental engineering challenge, and each one must work perfectly. The ongoing struggles show that even with 50 years of technological advancement, the moon remains a formidable objective.
Hostile environment.
The single greatest reason we haven't returned to the moon might be the moon itself. It's not a passive, dusty rock, it's an environment of violent extremes, fundamentally hostile to human life. As pulmonary physiologist Dr. Kim Prisk notes in his research, we still don't fully understand how dangerous its dust is to our bodies. The temperature swings are brutal, from 250 degrees Fahrenheit in the sun to minus 250 degrees in the shade. A 500-degree difference that can occur over just a few feet. With no atmosphere, there is no protection from radiation and micrometeorites. The electrostatically charged dust cuts like glass and invades every piece of equipment. The invisible gravity wells, or mascons, make stable orbits a constant challenge. This extreme thermal cycling can cause materials to become brittle and crack, a huge risk for long-term habitats. Even the very light and shadow create problems, with the low sun angle creating deep, dark shadows that can hide dangerous craters and rocks from landing spacecraft. What the new program is uncovering is not a conspiracy, but a set of harsh physical truths. The moon is an active, hostile environment that pushes back, and overcoming it is proving to be the hardest challenge we've ever faced. So, no, NASA didn't uncover a conspiracy. It uncovered something far more sobering: the raw, untamed hostility of space. The Artemis I mission served as a brutal reminder that the moon is not a solved problem. The heat shield failure, the radiation dangers, the abrasive dust, and the unpredictable gravity are not minor details. They are fundamental obstacles to survival. The greatest achievement of the Apollo program wasn't just getting to the moon in 1969, it was getting 6 crews back alive. What do you think is the biggest challenge we still need to overcome? Let us know in the comments below. Don't forget to like, subscribe, and hit the bell icon so you don't miss our next video exploring the future of the Artemis missions. Thanks for watching Simply Science.